So hi everyone. So today I will explain about chapter 1 for introduction to structure, which is for this subject analysis structure BFC 21403. Okay, so what is a structure? So structure is a system of connected fabricated parts used to support a load, and the function is carry the load and transmit forces. So you can see this is the bridge structure, okay, where it's used to carry the load of the deck and pedestrians, okay, and then it will carry the loads towards the supports here and then to the foundation at the bottom. So the important aspect in structural engineering, which is including number 1, planning, and then number 2, analysis, and number 3, design, which design including taking into account of the utility, the serviceability of the structure, the safety, economy, aesthetic, materials, and environment constraints. Okay, so when you do the design for another subject, structural design, so you need to take into the consideration of serviceability and also the safety factor for provide more safety, and also the economical design, okay, to not over design and then to save the cost of materials, okay, and then it must appear with nice aesthetic view, and then the materials that use, and then with environmental constraint. And then after the design stage, it will go to the construction stage. Okay, so this is the important aspect in structural engineering. Okay, so the classification of structures, there are many elements. Okay, so the structural elements, some of the most common, the more common elements from which structures are composed as follows. So number 1, you can see here there is a tight ropes, where it's for the steel structure and often referred as the tight rope or bracing struts, subjected to a tensile force, where you can see that this rod is subjected by pulling force, where is the tensile force, okay, and then subjected to tensile force, slender and are often chosen from rods, bars, angle, channels. These are the common type of parts that use. Okay, so classification of structure, you can see that this one is the typical plain truss. Okay, you can see that you have the strut bracing here, and then the tight bracing here, and also the strut bracing here again, okay, to tight this structure. Okay, so classification of structures, number 2 is beam. Okay, so beams, okay, so from previous subject that you learned before, from the mechanic of materials, you already learned to calculate the beams, okay, the loading, the shear force, and bending moments. So for this subject, you will more focus on the plain truss. Okay, you will calculate the load. So beam is often classified according to the way they are supported. For example, simply supported cantilever beams. I believe you guys are well understand with these two beams. Okay, primarily designed to resist bending moments. So for the beam, you will calculate the load on the top, either UDL, point load, and so on, the moment, and then you will calculate the shear force and then bending moment. You will get the maximum value of shear force and bending moment. So it is designed to resist the bending moment on top of it. Okay, so when the beam is required to have a very large span and the load applied are rather large, so the cross section may take the form of a plate girder. Okay, so you can see these are the types of the beams. Okay, so the first is simply supported, okay, and then followed by the fixed support. Okay, the fixed support here, and then cantilever beams, continuous beam. Okay, and then this is the plate girder that mentioned in the previous slide. You can see this is a top flange cover plate, and then the flange angle, and then the side plate, okay, which is the L-shaped side plate, and also the web plate. Okay, this is the web plate for it, and then the bottom flange cover plate. See, this is an example for the pre-stressed concrete girders are simply supported on the piers and are used for this highway bridge. So you can see this is the example of the pre-stressed concrete girders that you use for the highway bridge. So classification of structure, then just now we already mentioned two types of elements. So the third one is the column. Okay, so columns are generally vertical and it resists the axial compression, so the force will apply on top. Okay, so on top of it, it will have the compressions towards the structure. So the first one is the tightrope, where it sustain the tensile load, but for column it sustain the compression load, where it will have the compressions, the compressive loading. Okay, so columns are subjected to both axial load and also the bending moment, okay, from the beam column. So this is the column structure. So now we go to type of structures. Okay, just now are three types of structure elements, and now we go to the types of structures. Structures are combination of structure elements, and the materials from which they are composed is referred to as structural system. So each system is constructed of one or more four basic type of structures. So one is trusses, consists of slender elements and usually arranged in triangular fashions. Okay, and plane trusses is composed of members that lie in the same plane. So example like bridge, roof support. Okay, and space trusses are member as standing in three dimensions and are suitable for derrick and towers. So for this subject, we will focus more on the plane truss, which is the planar trusses. Okay. So classification of structure, you can see that these are the example for the derrick cranes, okay, for the 3D structures, okay. And number one, truss. Okay, truss is load that cause the entire truss to bend are converted into the tensile of compressive force in the members. So when we calculate for the truss, we will have the determinate truss and indeterminate truss in this. Okay, and then we will calculate the forces that sustained by each members, that either is in tensile or either is in compressive forces. So advantages of a truss. Okay, what it is use less material to support a given load, and can be arranged in various ways to support the loads. So it is also economically feasible to use truss to cover spans ranging from 9 meter to 122 meter or even more. Okay, so you can see that this is the example of a bridge truss, the truss bridge. Okay, and applied loading will cause the bending of this truss, which develops compression in the top member and tension in the bottom member. So you can see this member, okay, the top will have the compressions and then the bottom will have the tensions. You will be more clear about this when you learn the calculations in chapter 2, 3 and 4 for the trusses. Okay. Okay, so now we move to type of structure number 2, which is cables and arches. So for this type of structure is used to span long distance. Okay, it's used for a very long span. Okay, so for number 1, cables are which is very flexible and carry a lot in tensions. Okay, and used in bridges and also building roof. So bridges, there are many types, like you can see this in the Putrajaya bridges, and also you can online Google search, there are many of the cable type of the bridges. Okay, for span that are greater than 46 meter, you can see that is for very huge span, and it will not become unstable, where it can use to preventing from sudden collapse, and will have no added cost for construction if required increase in the depth as the span increase. So, but it's only limited by their sake, weight, and also method of anchorage. So types number 2, okay, you can see that the arches achieve its strength in compression, okay, reverse curvatures of the cables, and they must be rigid and frequently used in the bridge structure, dome roof, and also opening in masonry wall. Okay, so you can see these are the example for the cable bridge and also the arches. Arches is the arches type of this support. Okay, you can see these are the two types. So number 3, you also have frame. Okay, just now number 1 is the truss, number 2 is the cable and arches, and number 3 you have type of the frame, okay, used in the buildings and are composite of beams, columns that are either pinned or fixed connected. Okay, loading on frame causes bending of its member and it has rigid joint connections. So this structure is generally indeterminate from a standpoint of analysis. So it is indeterminate, we cannot calculate it with the regular determinate type of calculations. So it has its way to how to determine the loads and so on. Okay, so you can see that this is an example for the rigid type, which is normally welded, and this is the pin structure. You can see this. Okay, this is the pin structure and this is the rigid. So type number 4, which is the surface structures. So surface structure are made from the material having very small thickness. It's almost able to ignore the thickness. Okay, like shell structure. Sometimes this material is very flexible and can take the form of a tense or a air inflated structure. Act as a membranes, okay, membranes and subjected to pure tension. Only subjected to tension. So may be sharp as folded plates, cylinders, hyperbolic, paraboloid, and refer to a very thin plates or shells. Okay, as I mentioned before, the shell structures. Okay, so you can see that this is the example roof of the Georgia Dome in Atlanta, Georgia. Okay, it can be considered very thin membranes for the rooftop. So analysis. Okay, structure analysis is a process in determining the reaction of the structure under the specific loads or actions. So the actions usually measured by establishing the forces and deformation throughout the structure. So once the preliminary design of structure is proposed, the structure must be analyzed to ensure that it has its required strength and rigidity. Okay, so structural analysis is very important. So in order to analyze structure properly, certain idealization must be made as to how the members are supported and connected together. So there are assumptions, okay, need to be made. The loadings are determined from codes and specifications, and the force in the members and their displacement are found using the theory of structural analysis. So idealization of structure. Okay, so what is it? So in the process of analysis, the real structure has to be redrawn again in the form of line diagram. Okay, normally we will draw the free body diagram. So generally, most of the structure in 3 dimensions can be idealized in 2 dimensions. Okay, so you can see that this is the actual structure. Okay, so when we idealize it, you need to draw it. Okay, so from point A to B, you will draw like this. Okay, and then B to here, this point, you will draw like this, and then this is the force, okay, applied on it. So there is an F here, where you also listed the dimensions and also the support conditions. Okay, so you can see that this is a structure. Okay, the framing plan. Okay, so this is the joint, the slab, the columns, the girder, and then you will draw it, okay, together with the I-beam. And how is it located? The I-beam location is located like this, so you draw the I shape like this. Okay, and then so you can see that this is a fixed connected beam. So when you draw, you will draw fixed connected beam, and then with the I-beam, how is located. Okay, and then fixed connected overhanging beam. So you draw, when you draw the idealized beam, okay, this is the connection of the I-beam. Okay, and then this is the beam you have, and then there is another connections here, the support here. Okay, and then this is hanging. So this is how you draw the idealized beam. Okay, and this is a frame. So you can see that, for example, here you have a simply supported beam. Okay, and then here you have a structure, you have a load at here. Okay, so you have a distance A, B, and then you have another load P2 here. Okay, so you draw everything here, you will get this diagram. So the idealized process for simple structure, where you can see this is a plain truss. So you have the roof trusses, you have the members, okay, you have the joints and so on. So how we idealize this and discretize it? Okay, we will draw the structure as simply supported structure, and then of each member we have draw it out. Okay, So a complex structure may be idealized as a line drawing. We draw it into a line, okay, with together the dimensions and so on. Okay, so what is the structure problems? Okay, so now we can see that this diagram, okay, structure we can divide to stable or unstable. So this is what we need to determine as the first step to determine the structure either is stable or unstable. If the structure is stable, so it will also categorize as is it determinate type or indeterminate type. Okay, so there are equations for this to determine the structure type. And indeterminate type is due to the external condition or either internal, extra internal members or anything. Okay, unstable, if the structure is unstable, it's due to the static issue or either geometrical issues. Okay, so we will go further on this. Okay, so what is determinacy? So determinacy is when all the forces in a structure can be determined strictly from equilibrium equations. So the structure is referred as statically determinate. Okay, so for this you can see R equal to 3n. I believe every one of you are familiar with these equations. Okay, so reactions, okay, must be equal to 3 times the n, the parts. Okay, then it will become statically determinate. If the reaction is greater than 3n, so statically indeterminate, where n is the part. Okay, so R is the force and moment reaction. This one is for the beam structure. So if a structure is statically indeterminate, additional equation need to solve for the unknown reactions. Okay, and these equations, okay, which is the compatible equations, must equal to the degree of indeterminacy. So let's say simply supported beam 3, we know that is determinate with 3 reaction support. So let's say you have 4 reaction support, so which is mean it is indeterminate and it have 1 degree of indeterminacy because the it is with extra 1 reaction force. Okay, so stability, so it's to ensure the equilibrium of a system or its member. It is not only necessary to satisfy the equations of equilibrium, but the member must be properly held or constrained by their supports, regardless how the structure is loaded. So two situations may be occur when the conditions of proper constraint have not been met. Okay, so number one is partial constraint. A structure or one of its member has fewer reactions force than the equations of equilibrium that must be satisfied. So for example, you need 3 supports, 3 reaction supports, but you only have 2. Okay, which means it is fewer than the needed. Okay, so improper constraint, another type is improper constraint. Okay, so you have 3 reaction support, but then the location of the arrangement of the support are improper. For example, you can see that the reaction force are parallel. So you put this support all are parallels, okay, it's support to the reaction of force Y, and then but then you apply a lot like this diagonal here. So there is no reaction support at the horizontal direction, where when the load applied, this beam will slip through the horizontal directions because there is no support to sustain the load applied from P. Okay, so R is less than 3n, which will cause unstable, and R is equal to 3m, it is stable. But then if R is greater than 3n, which is unstable if the member is reaction with unstable if the member reactions are concurrent or parallel, or some of the components form a collapse mechanism. Okay, so the parallels mean here is all the pin support, let's say, so it will slip through the another direction of the horizontal direction if let's say the load applied as the previous slide. So if the structure is unstable, it does not matter it is statically determinate or indeterminate. So if it is unstable, then we cannot use it. Okay, whether it is determinate or indeterminate, it will not matter because the structure is unstable. Okay, so you can see that this is the equations for stability and determinacy classifications for beam, frame, plane truss, and space truss. From the previous subject that you learned before, the mechanics of material, you use this equation for the beam, R equal to m plus 3. Okay. Okay, so the n is number of internal hinge. So interhinge, if you have no hinge, means 0. 0 plus 3 is 3. So reaction, let's say you have 3 reactions and then you have no hinge, so 3 equal to 3, you will get stable and determinate. Okay, which is from the geometrical determinate, the stable. Okay, so frame, you will use this equation, which is 3m plus r equal to 3j plus n. And then for this chapter 1 to 4, you will most commonly see this equation is plane truss, which is we will learn about the calculation for it is m equal to 2j minus r. M is total member including in the plane truss. J is how many, the J is the joint. Okay, how many joint you can calculate. Okay, total it up, and the reactions, how many reactions. Okay, so you total it up, m equal to 2j minus r, you will get determinate and geometrically stable. But if the m is smaller than 2j minus r, it is statically unstable. And if it is greater than the 2j minus r, it is indeterminate. Okay, so this equation you need to memorize it and be familiar with it. You will also use it. So let's go to practice how to calculate the stability and determinacy of plane truss. So you can see that this is the first example. Okay, so M is member, so you have 1 member, 2 member, 3 member, 4 member, 5 members, 6 and 7 members. Reaction force, you have pin support and roller support. So 2 plus 1, you have 3 reaction force. Joint, you have 1, 2, 3, 4, 5. So it's 5. So m plus l is 7 plus 3, which is 10. 2 times joint, which is 5 joint, you have 10 equal to 10. So m plus r is equal to 2j, so it's determinate, and also this looks stable. Okay, so for number 2, you can see that this is number 2. Okay, you have also 7 member. We have member 1, 2, 3, 4, 5, 6, 7. 7 members. You also have crane support and roller support, which is you have 3. Okay, but then joint you have 1, 2, 3, 4, 5. So here is 10 equal to 10. However, it is determinate. But you from this, you can look at this. From A, B to C, there's a hinge here on the structure from A to C. Okay, A, B, B, C. There's a hinge here. Okay, so this one will cause the bend. Okay, you can see the dashed line is how will it bend. It is geometrically unstable. You can see that this is unstable here from the appearance. Okay, so you can see that this is geometrically unstable due to the hinge in one straight line. Okay, so from A to C is one straight line, but then you have B, the hinge here, so it will cause it to become unstable. Okay, so you can see that this example is 10 equal to 10, but it is also unstable. So why? Because the geometrically unstable due to parallel reactions, the horizontally unrestrained. So you can see that this is roller, which is support on the top, which is support to the vertical force, and also this is support to the vertical force. However, there is no support to the force, okay, to the horizontal force. There is no constraint about it, so it will become unstable when there are horizontal force applied. So this structure is also unstable. Okay, so there are other examples you can go through in this. You can check one by one and then practice on how to calculate by using these equations. Okay, so you can see that this is the last structure that you have 10 equal to 10 structure also. However, it is statically unstable due to insufficient members to brace panel A, B, C, D. A, B, C, D here. You can see that here there is nothing inside this here. Okay, there is no member here. So it is statically unstable. Okay, to sustain the horizontal movement. So when you apply the load from the horizontal at A, B or C, D, this structure will become unstable. Okay, so other than using equations, you need to use your logic thinking and on how the applied load will affect the structure to make it become unstable if you have these three types of unstable conditions. Okay, so thank you for your attention. So let's move forward to another chapter for another videos. So thank you.